Hello. All right. Let's see if we can't get through an introduction to organic nomenclature fairly quickly. I've already covered this in class a little bit, but let's go ahead and dive right into this as if I mostly have not. Okay. Now, you should have your chart of various prefixes and so on handy. Now, we are dealing with branched alkanes to start. Okay, so we're only looking at carbon and hydrogen, no substitutes, no substituents, I should say, and no double bonds, no triple bonds. Okay, so just single bonds to start with, and no substitutes. Now, so let's look at something. That's ugly. Let's look at something like this. Okay. Fairly simple. Now I'm going to go ahead and first we find the longest chain. Now that means, if you want to be, very careful, very punctilious about it, you have to go from every single end to every single other end, look at every possible pair, or you can learn to recognize that this is going to be the longest chain. Okay, don't be fooled into thinking that this guy down here is a side chain on the main chain. No, it could be the main chain. But if you have a problem with that, if you're not particularly good at that, then definitely just go ahead, count every single one. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 11, 10, 11, 12. Okay? You have those options, whatever works for you. Okay? I just want to stress that what matters most is that you get the right answer, not that you do it the same way I would. So now, if you have a tie, choose the one with more side chains, because more side chains are simpler side chains. Those are easier to name, they're easier to write, it's just better all around. But in this case, there's not really any possibility of a tie, so we'll just go on to step 2. You name your sides. Name your side chains. So we have one here, one here, one here, one here, one here. So this here has one carbon, so it's a methyl group. This is another methyl group, and another methyl group. This here has 2 carbons, making it an ethyl group. This has 3 carbons, making it a propyl group. But it's a propyl group attached at the second carbon. So prop-2-yl. Step 3, we number the main chain. When you number your main chain, you're always going to be faced with 2 options. From one end to the other, or from the other end to the one. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I miscounting? No, I'm not. 10, 11. Versus, this in blue, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I did miscount. 10, 11, 12. Okay, so, this is annoying. Okay, so 4, 5, 6, 7, 8, 9. I could go through and edit all this out, but I'm not going to because that would take longer. 12. Okay. So, now we list our side chains in alphabetical order. So we have our ethyl, and our 3 methyl groups, and then we have our propyl group. Now, looking at our orange numbering, our ethyl group is at number 6. Our methyl groups are at 2, 2, and 5. So 2, 2, 5. And then our propyl group is at number 8. Now, coming from the other direction, we have our blue. And our ethyl group under blue is at 7, and we can stop there because it's the first time we have a difference. First difference means choose the smaller number. And 6 is smaller than 7, so we go with the orange numbering. Now let's go ahead and name this based on the orange numbering. It is going to be 6. Put a dash in between numbers and letters. 6 ethyl. 2, 2, 5 trimethyl. Dash. 8 propyl. Now remember, M comes before P. So even though the T in tri comes after P, trimethyl still comes before propyl. And that changes when things go in parentheses and so on. Just remember that the tri goes on the methyl after you name the side chain. That's the important part. Okay. So trimethyl comes before propyl. So 8 propyl, and then this is 12 carbons long, so do, decane. Okay. Dec means 10, do means 2 more than, so dodec means 2 more than 10, or 12. And further, A and E is what tells us that this only has single bonds. No double bonds, no triple bonds. We will cover those starting, I believe, next week. All right, let's walk through another example. Let's see if I can't somehow come up with one that has some parentheses in it, because everyone loves parentheses, right? Okay. Now this one I'm not sure which is the longest, but let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. All right, so we choose the one that gives us the most side chains. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Aha! Don't even need to try. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going from that end of what looks like a side chain to that end of what looks like another side chain, giving us 1, 2, 3, 4, 5, 6, 7, 8 side chains. Well, this did end up still being fairly complicated. Most of our side chains are methyl groups, so we have 1, 2, 3, 4, 5, 6 methyl groups. We also have an ethyl group right there. This one over here is complicated, and that's what I wanted. Now, this is a recursive algorithm in the lingo of computer science, meaning that you apply the same sort of rules to naming a side chain as you would to the main chain. So we find the longest chain within this side chain over here. That's going to go from this end to this end, giving us a total of 1, 2, 3, 4, 5 carbons and a side chain coming off of it. Oh, and this is doubly instructive. I would like to pretend that I came up with this example on purpose, but I didn't actually. So we have a choice for how we number this side chain. Okay, do we go according to the blue numbering or according to the green numbering? Well, normally, for a side chain like this, you number it according to whichever gives the lowest number at the attachment point. But they are both 3. Okay. So it's going to be a pent 3-il, regardless. So that means that our choice is based upon the numbering of this methyl group. And that methyl group can either be at position number 2 or position number 4. 2 is smaller than 4, so we're going to go with the green numbering. So it is a 2-methyl pent 3-il. And having named that, this entire thing is the name of that side chain, and that's how we alphabetize it. Okay. It's going to be M. Okay. So it's going to be competing with these methyl side chains. Either way, the ethyl side chain is going to come first. Let's go ahead and number the main chain, now that we've named all the side chains. Okay, so we have option 1, 2, 3, 4, 5, 6, 7, 8, 9, versus 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a very ugly 9. 9. All right. And looking at this, we can see right here that the ethyl group is going to be the deciding factor. Okay, the ethyl group is either going to be 4 or 6. 4 is smaller, so we're going with our orange numbering. So we have, in order, 4 ethyl. Now, what comes first? Methyl or methyl pent 3-il? Ignore the number. Just go with the letters. Nothing always comes before something. Okay, the methyl simply ends before methyl pentyl does. So methyl is going to come first. So it's going to be 2, 2, 3, 6, 7, 8. 6, 7, 8. Hexamethyl 5 dash parenthesis 2 methyl pent 3-il close parenthesis nonane. Known because there's 9 carbons in the main chain. All right, these and many more examples will hopefully help you work your way through a very, very large possibilities. Okay? Organic nomenclature is more tedious than difficult. There's lots of possibilities for mistakes, but for the most part, it's possible to work your way through. Find the longest chain, find the chain with the most side chains, name your side chains, give the smallest numbering, and there you go. It can get more complicated later on, and it will, but rest assured you won't be seeing anything quite like this on the tests. Possibly on homeworks, probably not. Even on homeworks, I'll keep them a little bit smaller than this. This is just useful because it gives us the possibility for understanding the more complex things you have to do for organic nomenclature. So hopefully you can work your way through these using these examples.